In 1933, a phone engineer in New Jersey heard something he couldn't explain. Karl Jansky worked for Bell Telephone Laboratories. His job was simple: find the source of static interfering with transatlantic radio calls. So he built an antenna. A wooden frame on Ford Model T wheels, 30 meters wide, rotating slowly in a potato field. His colleagues called it Jansky's merry-go-round. He found 3 types of static: nearby thunderstorms, distant thunderstorms, and a steady, faint hiss, coming from a fixed point in the sky. The hiss peaked every 23 hours and 56 minutes. Not every 24 hours, every 23 hours and 56 minutes. That's a sidereal day, the time it takes Earth to rotate once relative to the stars, not the sun. It meant the signal wasn't coming from anything in our solar system. It was coming from the stars themselves. Jansky traced the signal to the constellation Sagittarius, the direction of the center of our galaxy. Something at the heart of the Milky Way was broadcasting, and nobody knew what it was. Jansky published his findings in 1933. The public briefly noticed. The New York Times ran a story. Then the world moved on. Bell Labs had other things to worry about. No major telescope was built to follow up. No major funds were allocated. But one man listened, an amateur radio operator in Illinois named Grote Reber. Working alone in his backyard, he built a 9-meter parabolic dish from scrap metal. Between 1937 and 1944, he produced the first radio maps of the sky. The galactic center glowed brightest of all. 2 men, 2 backyard antennas, and a signal that the rest of the world wasn't ready for. For decades, that signal sat in the back of astronomy's mind. Radio telescopes got sharper, dishes got bigger, and slowly a picture formed. In 1951, Australian astronomers Jack Piddington and Harry Minette pinpointed a bright radio source, right where Jansky had heard his hiss. They called the region Sagittarius A. But within that glow, something stranger was hiding. In 1974, astronomers Bruce Ballack and Robert Brown pointed the most powerful radio interferometer in the world at the galactic center. Radio interferometry, linking multiple telescopes together to function as one enormous dish, was relatively new. The idea was to give radio astronomers the same resolving power that only optical telescopes with giant mirrors could achieve. Except these telescopes pointed not at visible light, but at radio waves. And at the galactic center, radio waves passed through the dust that blocked everything else. They expected a diffuse cloud. Instead, they found a single, fierce, impossibly compact point of radio energy buried inside the larger emission like a needle in a haystack. It was tiny, unresolved, and blindingly intense. The source was so compact, they couldn't even measure its true size. Whatever it was smaller than any natural radio source they had ever seen. In 1982, Robert Brown gave it a name, Sagittarius A star. The asterisk came from atomic physics, where it means an atom in an excited state. Brown thought the discovery was that exciting. He was right. Here's the problem. You can't see the center of the Milky Way, not with visible light. 26,000 light-years of interstellar dust block everything. It's like trying to see through a wall. But infrared light passes through dust. And in the 1990s, 2 teams, led by Reinhard Genzel in Germany and Andrea Ghez in California, had the same extraordinary idea. If something truly massive hides at the galactic center, the stars nearby should orbit it like planets orbit the sun, except faster, much faster. So they watched, year after year, taking infrared images of the stars closest to Sagittarius A star, measuring their positions, month by month, season by season. These were not casual observations. Both teams were essentially racing each other. Genzel's team at the European Southern Observatory in Chile and Gez's team at the Keck Telescope in Hawaii, each developing better adaptive optics, sharper images, more precise measurements. Science as competition and the universe as the prize. And the stars were moving, not drifting, racing. Star S2, one of the closest, was clocking 7,650 kilometers per second. That's 2.5% the speed of light. Over 16 years, they watched S2 complete a full orbit, a tight, screaming ellipse around something invisible. something that warped the light of every star that passed behind it. In 2018, the gravity instrument on the Very Large Telescope captured infrared flares from gas orbiting near the center, hot plasma moving at nearly 30% the speed of light, circling just outside whatever was lurking there. The math is inescapable. 4 million times the mass of the Sun, packed into a region smaller than our solar system. There is only one object in physics that can do that: a black hole. In 2020, Reinhard Genzel and Andrea Ghez received the Nobel Prize in Physics. The citation read, "For the discovery of a supermassive compact object at the center of our galaxy." Decades of observations, thousands of infrared images, two independent teams arriving at the same conclusion from opposite sides of the world. There is a monster hiding in the dark at the center of the Milky Way. The Nobel Committee noted something remarkable. They were not rewarding a single experiment or a single observation. They were rewarding 30 years of accumulated patience. 30 years of pointing telescopes at the same patch of sky. 30 years of measuring the same stars again and again, getting sharper and sharper. Science done the slow way, which is often the only way science works at all. They couldn't see it directly. They couldn't photograph it, but they could see what it did to everything around it. Gravity wrote its signature in the paths of stars, and these two scientists learned to read it. That was about to change. To photograph a black hole, you need a telescope the size of Earth. So they built one. The Event Horizon Telescope is not a single dish. It's 8 radio observatories on 6 continents, synchronized to observe the same point in the sky at the same instant. From the South Pole to Spain, from Chile to Hawaii. 8 telescopes linked by atomic clocks functioning as one instrument with the resolution of a planet-sized dish. In April 2017, all 8 pointed at Sagittarius A star. For 10 days, they recorded 5 petabytes of data. So much that it couldn't be sent over the internet. It was loaded onto hard drives and physically flown to 2 supercomputers, one in Massachusetts, one in Bonn. Then came the processing, years of it. And this is where Sagittarius A star proved more difficult than anyone expected. Unlike M87 star, the first black hole the EHT had photographed 55 million light-years away, Sagittarius A star is turbulent. The gas around it moves so fast that it shifts and flickers on timescales of just minutes. Like trying to photograph a campfire with a very long exposure, the flames never hold still. The algorithms had to account not just for noise and atmospheric distortion, but for a target that was actively changing as they watched it. On May 12, 2022, they showed the world what they found. A blurry orange ring, a shadow at the center, light bending around something from which light cannot escape. The first direct image of the supermassive black hole at the center of our galaxy. The most important blurry photograph ever taken. It's there right now, 26,000 light-years away. 4 million solar masses of curved space-time sitting silently at the center of everything we know. Every star in the Milky Way orbits this thing. 200 billion stars, all bound to a point of no return that most of them will never reach. Including ours. Including the Sun. Right now, at this moment, our entire solar system is moving at 230 kilometers per second around the galactic center. One full orbit takes 225 million years. We have completed roughly 20 orbits since life first appeared on Earth. We are in the middle of the 21st. When Jansky first heard that hiss in 1933, he didn't know what he was hearing. When Bialik and Brown found the compact point in 1974, they didn't know what they were seeing. When Genzel and Ghez watched stars race around empty space in the 1990s, they suspected, but couldn't yet prove, what they were circling. It took 90 years of human effort, from a phone engineer's wooden antenna in a potato field to a telescope the size of a planet, to find what was hiding at the center. The light in the 2022 image, the orange ring that finally confirmed everything, left Sagittarius A star 26,000 years ago. Before agriculture, before writing, before civilization. We've been orbiting it for 4.5 billion years. We just didn't know.